Okay, arithmetic sequences and series. Now just let me mention right at the top that there's a few formulas for this, as there are for geometric series and all the other stuff. Go to the top of this page or the link at your left and you'll see a link to a cheat sheet of formulas for all this stuff. Check that out, print it out, it's a PDF, it's free, and that'll just be a good thing to have in your notebook to refer to give you, all the formulas you need for this chapter, instead of always having to flip open your notebook to find them. Alright, so arithmetic sequences and series. We already mentioned that sequences are when the numbers are separated by commas, and series are where the numbers are separated by plus signs. That doesn't really matter though when we're trying to find the terms, because usually what makes these problems a little bit tough is they're trying to get you to find like the 10th term or the 15th term of something, of a sequence of numbers. So you just have to know what everything means in this formula, which gives, this is the explicit formula, because hey, if I wanted to know the 10th term, all I have to know is the first term, not the 9th term. The recursive one is the one where you have to know the term before. And therefore, if you want the 10th term, you'd have to find terms 1 through 9 first. All right, so what's the vocabulary here? So t sub n, that basically means the nth term. So if I wanted to find the 10th term, I'd be looking for t sub 10, the 10th term. That little 10 means 10th. Term, and t stands for term, so term number 10 is going to equal the first term plus, now whatever number I put down here, so in this case it's 10, I'm going to plug that same number in for n right here. So it's going to be 10 minus 1. And then d is the common difference, or the number that we have that's going to be the difference between each successive term. Because remember, in arithmetic sequences, we're just adding a certain amount to one term to get the next one, then we'll add that same amount, d, to that term to get the next one. We're just leapfrogging by the same distance each time. So in this example, we add 2 to get from 1 to 3, then we add 2 to get from 3 to 5. We'll just keep adding 2, adding 2, adding 2 again and again. Forever, I guess, because there's a dot, dot, dot. So the question is, find a 15th term. Well, if I wanted the 15th term, that's just t sub 15. And I'm saying t sub 15, meaning subtext or subscript 15. That little 15 is small and it's down, so they call it subscript. So t sub 15 is going to equal t sub 1 plus 15 minus 1 times d. So let's just plug in the numbers we know. T sub 15 is going to equal t sub 1, which is 1. So that's just the first term. 15 minus 1 is 14, and then d is that common difference, which is 2, right? Because we're jumping 2 to get from term to term. So that's just 1 plus 28 is 29. Super easy, right? When they ask you for the nth term, sometimes it's really easy if they gave you the first term. Slightly juicier here, they're giving us the terms, they're asking us to solve for the common difference, which is d. But once again, I can just plug into the equation again and solve for d this time instead of t sub n. Now which thing should I put on the left? T sub 1, t sub 5, t sub 25? Well, since they gave me the 8th term, that means I want to put t sub 8 on the left. And then of course if I put t sub 8 on the left, I've still got t1 here, and then n is going to be 8, so I got 8 minus 1 times d. Now I can plug in all these numbers because they've given me all of them except for d. D is the one thing they haven't given me, but that's what I'm trying to solve for. So I'm just going to plug in everything I know. They told me the 8th term is 39, so 39 gets subbed in there. Then t1 is the first term, but they gave me that. The first term is 4. So 4 plus, and then I can just do that. 8 minus 1 is 7. And then d, we don't know. That's what we're solving for. So all I got to do is now solve for d, subtract 4 from both sides. I get 35 equals 7d, which means that d equals 5. Pretty sweet. Not too bad, right? Now these do get a little bit trickier. You notice what really sets these two questions apart is they gave me the first term, which is really key because this explicit formula has t sub 1 in it. So if they give you the first term, what's the worst they can do? They can either ask you for n, they could ask you for d, but it's usually pretty straightforward. And the harder ones, they won't give you that first term. So for example, in this one, I've got the 6th term and the 8th term. What a pain in the butt. They're not asking me for d this time, they're asking me for the first term. You'll notice that the first term is right here, it's in that equation. So if I could figure out d and then just plug in some term, I'd be able to solve for t1. So let's take a look at it. Now a good strategy when you're not sure what's going on is to write your terms and label them. So if I know that the 6th term is 38, that means I could write a 38 here, and then I'm going to write just 6 below it because it's like term number 6. And And I know the 8th term is 46. So we got to have 46 here and I put an 8 there. Now the key here, does this mean my D is just going to be 48 minus 36? Well, not quite. There's a missing term, right? What about term number 7? What I could do is just put a blank in there. And this will allow me to solve for my common difference. So if I look at this, I'm like, well, 38 to 46, I cover two D's, right? Because I'll have to add D to get from here to here. And then I'll have to go D again to get from there to there. So that means that 2 leaps, 2 D's, is going to equal whatever 48 minus 36 is, which is 8. So look at that. I can just solve for D equals 4. That would be a little bit juicier if instead of giving me 2 terms that were 2 apart, if they'd give me like terms 26 and 36. But then I'd be like, oh, well, to get from 26 to 36 is 10 jumps. So that would mean that 10D equals whatever the difference is between those terms. So the point is that we could solve for D equals 4, and that's going to go in right there, right? So I've now turned this equation in to T sub n equals T sub 1 plus n minus 1, and now I've got D is 4. So am I there yet? Well, yeah, because if I just knew a single term, I could plug in. So what I'm going to do is I'll just use one of my 2 terms. I could use the 6th or the 8th. I'll use the 6th since I saw it first. So T sub 6 equals T sub 1 plus, now this 6 is just what goes in for n right here, right? So that's just going to be 6 minus 1, and all that's times 4. Now I'll just plug in the term I know, T6 is 38. So 30, if I take this up here, T sub 6 I know is 38, and that's going to equal all this stuff. So T sub 1 plus 6 times 1 is 5, 5 times 4 is 20. So I subtract 20 from both sides, and I got T sub 1 equals 18. Pretty good, right? Now we've added another little part of the problem is, what is the 15th term of that same sequence? Well, now that I've got T sub 1 equals 18, I can just plug straight in. I'll just get that T sub 15 equals T sub 1 plus 15 minus 1 times D, which is still 4. So I get T sub 15, which is what they're asking me for, equals T sub 1, which I just found is 18, plus 14 times 4. Oh man, 4 times 14, 56, plus 18. 16 is 14, so 74. Correct me if I'm wrong. All right, 74. Now you can see a lot. I was pretty nice in a way. Because I asked this slightly tricky question of finding the first term first, then I asked for the 15th term, I sort of led us step by step through the process. The hardest teachers, though, will just give you this question on its own. They'll say, if the 6th term of a sequence is 38, and the 8th term is 46, they'll just give you that, and then instead of asking for the first term, they'll ask for the 15th term, like I did here. They won't take you step by step through the process about figuring out what the first term is. But that's often what you should do. If you want to know, if they give you 2 wacky terms and ask for another wacky term, all you do is use the first 2 wacky terms to solve for the first term the way we just did. And then once you got the first term, you can plug that into the equation to get any wacky term you want. All right, finally I want to mention arithmetic means. After this we'll do the sum formula. Arithmetic means, what are these? Those are just terms. So they say find 3 arithmetic means. What they're saying is, hey, we've got a sequence that's got a 3 in it and an 11, and then between that we want 3 other terms. So blank, 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 and these are arithmetic means, which means we want an arithmetic sequence that has 3 stops in it between 3 and 11. So what you got to figure is, you know what? To get from 3 to 11 is going to take 4 jumps. 1, 2, 3, 4. So that means that 4 times D is going to equal 11 minus 3, which is 8. So D equals 2. So that means I'm just counting by 2s. So 3, 5, 7, 9, 11. Works out, right? No big deal. And that kind of always works that way. The real trick is, if they're asking for 3 arithmetic means, we had to jump 4 D's. And that's always going to happen. There's just like that extra leap to get to the first term. So just remember the x plus n plus 1, n minus 1 confusion. Just be real careful. You know, if they had said, hey, find 20 arithmetic means between 15 and 36, you would want to make sure that you plugged in 21D in order to find 20 arithmetic means. Finally, the sum formula. This is really pretty straightforward. That's why I put it last. The sum of any number of terms, so this S sub n, what that means is the sum of n terms. So if you want to find the sum of the first 10 terms, that means, like in this example, that means we're looking for S sub 10. And that's going to be n over 2. So once again, this is our n. So 10 over 2 times a1, which is 1. Now the only trick here is we have to find a sub n. We have to find the 10th term in order to plug it into our formula. So what is the 10th term? Well, t sub 10 is going to be t sub 1 plus 10 minus 1. This is just using the explicit formula we used in the previous problems, times d, which appears to be 2. So t sub 1 is 1 plus 9 times 2. So the last term is 19. So now we've got 10 over 2 is 5, and 1 plus 19 is 20. So that's going to equal 100. Pretty easy, right? The tricky part is in a problem like this. So this formula, it says the sum S sub n, so that's usually the sum of the first 10 terms or whatever. But in this one, they're asking for the terms 5 through 12. Well, it turns out we're still going to do the same process. We're just going to plug in, so it turns out the sum of terms 5 to 12 is just going to be the number of terms over 2. So how many terms is this? Let's see, 5, 6, 7, 8, 9, 10, 11, 12. So 8 terms. Because this n right here is really just the number of terms I'm adding up. So 8 over 2 multiplied, and then I just need the first term and the last term we're looking at. So I need the 5th term, and I need the 12th term. So in both cases, it's going to be the first term, which they told me is 4. And then I need 5 minus 1, and minus 1. And they told me d is 4. That was nice of them. Now in this one, it's going to be, since I'm finding the 12th term, it's going to be 12 minus 1 times 4. All right, so 5 minus 1 is 4. 4 times 4 is 16, plus 4 is 20. So 20 goes right here. And then for this one, 12 minus 1 is 11. 11 times 4 is 44, 48. So 48 is going to be my last term, because this is t sub 5, this is t sub 12. Oh man, so 4 times 68. 4 times 68, 272. Pretty crazy, right? All right, so that's how we use the formulas. As you can see, the simplest ones are when you're looking for a term or the sum of some terms, starting with the first term. And if they give you the first term, it's super easy. Then the way they make them a little bit trickier is by giving you later terms, asking for the sum of a chunk of terms, not starting at the beginning. Whenever you're not starting at the beginning, that's when it's tough. But if you just practice a little bit, practice working backwards, maybe you have a nice teacher that doesn't throw the hard ones at you. So either way, the formulas are your friend. You have to memorize them and write them down at the top of your paper when you first hit down. Or a lot of teachers let kids take in formula sheets for this chapter just because there is so much kind of stupid stuff to memorize.